Hello, greetings to everyone. I am Madhukrishna Priyadarsini from KIT University. I am going to present my research work on SDN implemented adaptive load balancing scheme for mobile networks in 18th ICDCIT 2020. The co-author of this paper is Padmalochan Bera from Indian Institute of Technology, Bhubaneswar. So here I'm going to discuss a load balancing scheme for the MANET, but it is the combination with software defined network architecture, how software defined network we have integrated with MANET, and how we are going to solve the load balancing problem. So these are the outlines of my talk: introduction, SDN overview, MANET and SDN integration framework. Here how the integration we have made in the MANET platform and how the mobile networks, the base stations are presented. Then the formulation for this load balancing scheme, problem formulation, and then the solution, the self-adaptive load balancing scheme. It is a heuristic solution because we all know that load balancing is a NP complete problem, and then the experimental evaluation, conclusion, and the references. Now coming to the introduction, we know that the mobile networks is having four major concerns, or the MANET is having four major concerns: security, performance, scalability, and reliability. Why security? Because whenever we are moving the mobile nodes from one radio range to other radio range, then the security is a major issue, as well as the performance is going to be degraded, and scalability and reliability is also other issues. The another major concern is the dynamic requirements of the network, because in traditional network, MANET is derived from the traditional network. So in the traditional network, whenever you want to change something on the fly, that is very difficult, because the control programs are, as well as the data those are governing the control programs, are present inside a single hardware device. Either it is a router or it is a switch. Both the raw data as well as the control programs, those are governing those raw data, are present inside a single hardware device. So to change anything in the software, we need to switch up the hardware, or we need to upgrade the hardware. So that is very complex thing, and in MANET also the same problem is arising. So to solve this dynamic requirement as well as the security, performance, scalability, and reliability, we have integrated the software defined network inside the MANET. So software defined network, it is the future of the internet. In early 2010, this area came into research, and whenever I started my research in mid of the 2016, then it was a quite new area. But nowadays in 2020, it came to a long way. So coming to the overview of the SDN, it is different from the conventional or the traditional network in these four characteristics. One is your feature wise, it is decoupled the control plane and the data plane. All the data are present inside the forwarding devices like the switches and routers. They do not have any kind of control programs over here. The control programs are separately placed in some other hardware device. That's why they are only the forwarding devices. Whatever the task is assigned to them, they are going to do it. They do not have the brain to think, or they do not have the program how they can manipulate, or how they can manage the data. They are just the forwarding devices. And the control plane, which is having the controller, it contains all the programs, and according to the programs the data are going to be managed. But in case of your conventional network, it is a complex problem, because all the data and the controllers are placed inside a particular device. Now coming to the configuration, it is a automated configuration with a centralized structure, because the controller program is placed in a particular device. And in case of the distributed network, we know that there is not a single controller, there are many controllers present. So we can say that it is not a fully centralized, it is also a distributed network. But in case of your conventional network, it is a manual configuration. Whenever you want to upgrade something, you need to do it manually, so errors are coming there. And in performance wise, it is dynamically controlled, globally available with the cross layer information. SDN is having three layers. One is your control layer, one is your data layer, one is your application layer. So in the next slide I will discuss those things. And innovation wise, it is easy software upgradation as well as sufficient testing environment and quick deployment. But in case of conventional, it was difficult hardware implementation with a limited testing environment. And it is originated from the open flow with the centralized controller. It is easy to program, and dynamic routing policies also we can change. That's why it is providing us the network abstraction and the function virtualization. These two are the main benefits of using the software defined network. Now coming to the integration platform, in the MANET and SDN integration, in SDN we are having three layers. One is our application layer, where all the application plane resources like our web servers, our application servers, or any application softwares are present in the application plane. And control plane is having only the controllers. Inside the data plane, all the forwarding devices like our switches and routers are present. And if we integrate with the mobile node, we are placing all the mobile devices or the mobile nodes inside the data plane, because they are only the point of contact whenever they are sending some request and receiving some request. So those are present inside the data plane. And the control plane of the mobile network or the MANET is the base stations, which are going to, or the access points you can say, which are going to control the whole network. So here we are considering the distance constraint, the radio range of the mobile nodes. And then coming to the application plane, it is having the satellite. So satellite is going to send only the signals, so that's why it is only present inside the application plane. So in this way we have integrated the MANET devices as well as the SDN devices, and the controller, which is the brain of the software defined network, it is present inside the base station, which is in the control plane only. Now coming to the problem of the load balancing. So here the load balancing problem we have formulated considering the two problems. First one is okay, let me first discuss how the load of the base station is going to increase. So here we are going to solve the base station's load. Whenever any mobile device is going to connect with the base station is controlling everything of the mobile devices. If you are sending something to the outside world, or some message is coming for the mobile nodes, then it is going to be handled by the base station only. It is going to send it. That's why the load on the base station is going to increase, not on the mobile nodes. Mobile nodes are just forwarding, it is sending signal and receiving the signal, but the management is done by the base stations only. So if many devices are connected to a single base station, and their request is very high for either sending or managing, then the load is going to be increased. So what is the load of the base stations we consume or we considered here is the number of requests per second from all the mobile nodes connected to a particular base station is the load of the base station. And then if the load of a particular base station increases, then it need to be solved, or it need to be balanced. Then how it will be balanced? It is going to migrate some of its load to other lightly loaded base stations, or it is going to manage by its own. So the two problems we have solved here, the migration as well as updating our own threshold value, or updating the current updating the base threshold of the base station which is loaded. So what is base threshold? Base threshold we have considered the 75. We have taken a range of the hardware capacity, where hardware capacity of the base station, or we can say where the controller is implemented, that is in the range of 75% to the 90%. So here we have taken the base threshold minimum as the 75% and the maximum as 90%. Why this range? Because beyond 90%, if you are going to take your base threshold value, then it is going to create an impact on the hardware device where it is implemented. That's why we have taken the range, and within that range we can increase the threshold and decrease the threshold, and accordingly the load can be accommodated. So to solve these two problems, we have considered the three constants, because constants are any network, to solve any problem in the network, you need to take all the networking constants. So the first constant we have taken as the network association constant. That means whenever we are migrating something, we need to check whether the target base station where we are migrating is not creating any other load balancing problem, because if the after migration the load is going to increase, then another load balancing problem is created in the target base station, and then again we are going to provide the solution for that one. So in every device present or every base station present in the network, they are going to solve. So that is not a solution. For the first constant, we are going to check the network association constant, and the second constant is the load balancing constant. So here we are checking the base threshold is for the target device is increasing or not. Next we are checking the distance constant, and the distance constant is whenever we are migrating, we need to check whether the radio range is a particular minimum value we have taken for that. This capital D is the particular range, and within that range we can migrate. Beyond that range we cannot migrate, because there are geographical constraints added whenever we are going to migrate the mobile nodes. So to avoid those things, we have taken a particular value for the migration. This distance is the migration distance. So all these three constraints along with these two problems, we have created our load balancing problem, and all the mathematical stuffs are present in the a whole paper itself. Here just the problem formulation small part I have taken. Next, for the solution of this problem, we have taken a self-adaptive load balancing scheme. It is a heuristic approach, because we know that in any field the load balancing problem is a uh, NP complete problem, and in our earlier paper where we have taken, or where we have introduced this load balancing scheme for the software defined network, we proved it that the load balancing problem in SDN is a NP complete problem, and if we'll implement it inside MANET also, definitely it will be NP complete problem. So our scheme is having four major modules. One is our load measurement, load broadcast, load balancing, and load migration. And the load measurement, it is going to the base station. So let me clear first, we are going to do the load balancing inside the base stations only. The mobile nodes are just sending and receiving, the satellite is only sending the signals, so there we cannot do the load balancing. Whoever is the device, whoever is managing, we are going to do the load balancing there. And here the inside the load measurement component, each base station is going to measure its own load. And what is the load? The combination of the request per second from all the mobile nodes is the load of a particular base station. And inside the load broadcast, inside the load broadcast module, every base station is going to broadcast its own load to other base stations. And how it is going to broadcast? It is having a condition. If the current load is increasing 10% more than the previous load, then we are going to send the broadcast request. And why this condition we set? Because if we will do frequent load broadcast message, then it is going to create a traffic in the network, and which is unnecessary, because we do not know whether load migration is required or not. We are just informing other that this is our load. So frequent load balancing load broadcast message is not required also. And if there is a very large gap also, then if any load balancing condition is required, but we are not sending any messages to other base stations, then the load balancing problem is increasing and increasing, and nobody is going to solve that. That's why we kept this range or this condition. Now coming to the load balancing problem, here we have taken two scenarios. One is our uniform distribution and non-uniform distribution. In case of uniform distribution, all the base stations present inside a single network is having approximately equal load. And in non-uniform condition, one base station is having high load and other base station is having low load. So in this condition, we can migrate the load from highly loaded base stations to the lightly loaded base stations. So in non-uniform condition, we are going to migrate the load migration component is connected directly. So if the algorithm is finding there are lightly loaded base stations are present, then directly it is migrating the load from highly loaded base stations to lightly loaded base station. And how the migration is happening? First, the source base station is going to send a message, a request message, that this mobile node's load I am going to migrate to you, so you please check whether you can accommodate this load or not. So after getting this request message, the lightly loaded base station, it is going to calculate after receiving this mobile node's load whether my base threshold is going to increase or not. If it is not increasing, then it is going to accommodate, but if it is increasing, then it will send a NAC message, sorry, I cannot accommodate your load, you please find out some other lightly loaded base station. And then the source base station is sending the same message to other lightly loaded base stations, because it is having the load of each and every base station present in the network. So in the broadcast phase, everybody is having others current load value. So it will send, and from any of the device, if it is getting the migration, then acknowledgement request for acknowledgement message for the migration, then it is going to migrate. Otherwise it is going for the uniform distribution, or otherwise it is going to the uniform distribution condition. And in the uniform distribution condition, all the base stations are having approximately equal load. So there is no lightly loaded, no highly loaded, everyone is having equal load. So how to solve this? For this, we are going to implement our base threshold condition. So in the base threshold, I already told that we are having a range from minimum base threshold to maximum base threshold. So the 75% of the hardware capacity is our minimum base threshold, and 90% of the hardware capacity is our maximum base threshold. So within that range, we are going to increase the base threshold and decrease the base threshold. If the load is high and we are not finding any lightly loaded controller base station, then we are going to increase the load of our own as well as the other lightly loaded controllers base stations base threshold. And if they can accommodate, then we can migrate. Otherwise inside our the source base stations load is also fine, it can manage. And here in the uniform distribution condition, it is checking also the distance constraint. Whenever you are migrating, you need to check whether the distance in both the cases, uniform and non-uniform, it is checking the distance constraint, whether inside the radio range length is given as per the value, the D, capital D value is perfectly fine, because the geographical condition also we need to check. Otherwise we cannot send our migration from very large distance. So for this, the algorithms are load balancing algorithm. We have taken the range whenever we are increasing. Okay, first let me explain this one. If the current load is increasing the base threshold minimum value, then we are going to uh, balance the load for that base station. And in the load balance, we are checking whether the current whoever is getting the migration request is checking whether I can accommodate the load or not, the base threshold is increasing or not. If it is less than that, then you please migrate your load, and if it is not, then you just need to increase the base threshold value. It is sending that you please increase your base threshold value by 10%. And here why 10% we are increasing? Because if we are increasing within 10% and the load can be accommodated, then it is fine, no need to increase very high. But if you cannot accommodate within the 10%, then again another 10% it will increase, and the highest limit is your BT max value, that is the 90% range, and beyond that we cannot accommodate the load. And if it is not accommodating, then how the threshold is increased here? It is increasing one by one, 10% by 10%, and if it is finding that the BT max value is increased, the current BT is increasing the BT max, then it is sending the NAC value. And if it is not increasing, then it is sending a acknowledgement message, and then the load is migrated. And similarly, as we are increasing, similarly we also need to decrease, because always it is not the condition that the network is highly loaded, sometimes it is lightly loaded also. So in that condition also we need to decrease the base threshold value, and similarly the 10% we are decreasing till we reach the BT mean value. And in this way we are increasing and decreasing and accommodating our own load. That's why the name of the algorithm we have given as self-adaptive. Whenever there is a condition, it is increasing, and whenever there is a condition, it is decreasing. And now coming to the load migration, here we are finding out the lightly loaded controller, the base station is finding out, because it is having other controllers load. And once the lightly loaded controllers are find out, it is sending it is checking, first it is checking whether the distance constraint is validating or not, and also it is not creating any other load balancing constraint, because after sending, if there is another load balancing problem arise, then we are done, we cannot accommodate or we cannot successfully implement this scheme. That's why two conditions we are checking, and if these two conditions are satisfied, then you can migrate. Otherwise you will find any other device or any other target base station. And after receiving this migration request, it is going to check whether the migration can successful or not, and if it is sending the accept message, then it is going to send. Otherwise the reject message also you can send. Then any other device it is finding out and migrating the load. So this is all about our self-adaptive load balancing scheme. And for the experimental evaluation we have taken both the simulation as well as the emulation platform, and these are the specification for both simulation as well as emulation platform: Linux 64-bit, 4 GB RAM, floodlight controller, mininet traffic generator for generating the traffic, and BTSCR Pacific topology. And in emulation platform, it is SDN testbed. Actually, this software we bought from a Chinese company. Those are providing complete emulation testbed for the SDN implementation. And this MT198T, this is an open flow switch which is used for the SDN implementation only. And we have calculated the performance as well as the accuracy. And in performance we have checked the load on the controllers. Here five base stations as well as 140 mobile nodes we have taken. And first, without implementing the load balancing scheme, we have seen that the base station B1 and B2 are highly loaded, and B3, B4 and B5 are lightly loaded. And after implementing our salve scheme, we found that all the load is approximately balanced, and we can see that no one is highly and no one is lightly loaded here. Then also we have compared the throughput and packet drop for our salve scheme with the existing load balancing scheme in the managed environment, and we can see that the throughput is very high than the other two, as well as the packet drop is less. So here also we have shown the control overhead. The control overhead is the control messages, extra control messages that that has been created during the SALV scheme implementation, and this is the load balancing time, the throughput, as well as the packet drop. So here hash m is the number of message exchanged during the implementation of the SALV scheme. And in the accuracy verification, we have uh, uh, calculated the load and compared both the simulation and emulation platform, and we found that there is a very little difference between the simulation and emulation platform load balancing time, very less, as well as the load is balanced perfectly. In terms of loss rate, like that is our packet drop rate, as well as the load balancing time we have compared. So this is for the load balancing time comparison, it is very slight difference, as well as the loss rate is almost equal. Now coming to the conclusion, we have presented a self-adaptive load balancing scheme for mobile networks in integration with the SDN controller architecture. Here we solved the problem in two ways, non-uniform distribution and uniform distribution. In uniform distribution, the threshold is adjusted dynamically, and wherever it is suitable, the target can migrate its own load. And in case of non-uniform, it is finding a lightly loaded base station and migrating the load. And coming to the experimental results, we have seen that the SALV is effective with low packet drops, almost less than 1%, and high throughput 9.72 Mbps. So these are the references, and this paper we have implemented the SALV scheme in the SDN platform, and these are some supporting papers where the SALV, before coming to the SALV scheme, how the SDN traffic generation and how the uh, traffic is managed, all these two things are present in these two papers. So completely on the SDN area, all these three are, but this time we take a step to implement in other environment. Like we are having another paper where in the smart city renovation we have implemented, but we thought that we'll go for the managed, and we will see how the result is varying, because you know that SDN can be implemented in any area, whether it is WSN or it is managed or any other area. That's why the chance we have taken, and these are certain other references that you can find out. Thank you everyone for giving your time and listening to me for my research. Thank you.